In this lesson, we are going to solve ESSLCE mathematics of the year 2012-2013 Ethiopian calendar. Question number 1. Which of the following statement is not true? All the choices are focusing on variance and variability, so let's discuss what it means. Variance is a measure of dispersion that takes into account the spread of all data points in a data set. It is mean squared difference between each data point and the center of distribution measured by the mean. Variance is calculated by the formula variance squared is equal to summation of frequency times the square of the difference between individual value minus the mean divided by the summation of frequency. If individual values are closer to the mean, the square difference between each data point and the mean is smaller, otherwise it's higher. So we can conclude that the lower the value of the variance means the data sets are closer to the mean, and the higher the values of variance means that the spread of data values from the mean is higher. Except choice B, all other alternatives are true. So choice B is the answer. Question number 2. The following is the frequency distribution of a grouped data. Class interval, frequency 3 up to 7 with the frequency 2, 8 up to 12 with the frequency 2, 13 up to 17 with the frequency 10, 18 up to 22 with the frequency 6. What is the mean of the data? The following are the steps to solve this problem. Step 1. Determine the mid value of each class. Mid value is the average of the class limit. So the mid value of the class 3 up to 7 is 3 plus 7 divided by 2. 3 plus 7 is 10. 10 divided by 2 is 5. The mid value of 8 up to 12 is 8 plus 12 divided by 2. 8 plus 12 is 20. 20 divided by 2 is 10. The mid value of 13 up to 17 is 13 plus 17 divided by 2. 13 plus 17 is 30. 30 divided by 2 is 15. The mid value of 18 up to 22 is 18 plus 22 divided by 2. 18 plus 22 is 40. 40 divided by 2 is 20. Step 2. Multiply the mid-class value by the frequency of the corresponding class. That means multiply column 2 and column 3. 2 times 5 is 10. 2 times 10 is 20. 10 times 15 is 115. 6 times 20 is 120. Step 3. Calculate the sum of the frequency as well as the frequency times the mid-class. That's calculate the sum of each of second and fourth columns. The sum of second column, 2 plus 2 plus 10 plus 6 is equal to 20. Sum of the fourth column is 10 plus 20 plus 150 plus 120, which is equal to 300. Step 4. Calculate the mean by using the formula summation of frequency times mid-class value divided by the summation of frequency. Summation of frequency times the mid-class value is already determined as 300 divided by the summation of frequency is 20. 300 divided by 20 is 15. Choice C is the right answer. Question number 3. Let f of x is equal to x squared minus x divided by 2x squared minus x minus 1. Which of the following is not true about f and its graph? A. The graph of f has hole at 1, 1 over 3. If there is a common factor in the numerator and denominator of a rational function, there is a hole at the point that make that common factor 0. F of x is equal to x squared minus x divided by 2x squared minus x, which is equal to x is there in both terms of the numerator, so we can take it x as a common factor. X squared divided by x is x, minus x divided by x is 1, the whole over the denominator, that's 2x squared minus x minus 1. To factorize this denominator, find two numbers. Their sum is negative 1, that is the coefficient of the midterm x, and their product is negative 2, that is the product of the coefficient of x squared and the constant. The two numbers are negative 2 and positive 1. So this second term, that's negative 6, can be expressed as 2x squared minus 2x plus 1x minus 1, which is equal to 2x is a common factor for the first two expressions. So we will take it 2x as a common factor. 2x squared divided by 2x is x, minus 2x divided by 2x is 1. 1 is a common factor for the third and the fourth expressions. So we take out 1 as a common factor. 1x divided by 1 is x, minus 1 divided by 1 is 1. X minus 1 is a common factor for both expressions. So we take out x minus 1 as a common factor. We left with 2x in the first expression and plus 1 in the second expression. So the factorization of the denominator, 2x squared minus x minus 1 gives 2x plus 1 times x minus 1. X minus 1 is common to the numerator and the denominator. The number that make x minus 1 is equal to 0 is 1. Hence, the graph of f has hole at x is equal to 1. When x is equal to 1, f of 1 is equal to 1 divided by 2 times 1 plus 1, which is equal to 1 divided by 2 times 1 is 2 plus 1 is 3, meaning the whole is at 1, 1 over 3. So choice A is true. Choice B, y is equal to 1 over 2 is a horizontal asymptote. Horizontal asymptote describes about the graph of f as the value of x approaches to negative infinity to positive infinity. Depending on the degree of numerator n and the degree of denominator d, we have three different possibilities for horizontal asymptote. If the degree of numerator less than the degree of denominator, then the horizontal asymptote is the x-axis, or y is equal to 0. If the degree of numerator is equal to the degree of denominator, then the horizontal asymptote is y is equal to ratio of the leading coefficients. If the degree of the numerator greater than the degree of denominator, then there is no horizontal asymptote, rather we have a slant asymptote. In this particular case, the degree of numerator is equal to the degree of denominator, then the horizontal asymptote is y is equal to the leading coefficient of the numerator divided by the leading coefficient of the denominator. Leading coefficient is the coefficient of the highest power. So the highest power in the numerator is x squared. The coefficient of x squared is 1 divided by the highest power in the denominator is again x squared. The coefficient of x squared in the denominator is 2. So the horizontal asymptote is y is equal to 1 over 2. Choice B is true. Choice C, x is equal to negative 1 over 2 is a vertical asymptote. The vertical asymptote of a graph is a vertical line, x is equal to a. The vertical asymptote of a graph is a vertical line, x is equal to a, where the graph tends towards positive or negative infinity as the input approaches to a. It describes the graph as the output approaches to negative infinity to positive infinity. The following are steps to determine the vertical asymptote. First, factorize the numerator and the denominator. Second, cross out common factors from numerator and denominator. We already worked out on these two steps in choice A above. Step 3, set the simplified denominator is equal to 0 and then solve for x. The simplified denominator is 2x plus 1, which is equal to 0. Take plus 1 to the other side of the equality and divide both sides by 2. We find x is equal to negative 1 over 2. Thus, x is equal to negative 1 over 2 is a vertical asymptote. Choice D, f is an even function. Even function satisfies the condition f of x is equal to f of negative x. F of x is already given, x squared minus x divided by 2x squared minus x minus 1, which is equal to f of negative x is negative x squared minus negative x divided by 2 times negative x squared minus negative x minus 1. This implies x squared minus x divided by 2x squared minus x minus 1 is equal to negative x squared is x squared minus negative x means plus x divided by 2 times negative x squared is x squared, 2 times x squared is 2x squared, minus negative x is plus x minus 1. The equation or the expression at the left is not equal to the expression at the right, so this expression is not true. That means f is not an even function, so the correct answer is choice D. Question number 4. Let A is equal to a 2 by 2 matrix having first row elements 1, 2 and second row elements 3, 4, and B is equal to a 2 by 2 matrix, first row element 2, negative 1 and second row element negative 1, 3. Then which of the following is equal to 3a plus 2b. In a scalar multiplication, each entry in the matrix is multiplied by the given scalar. Hence, 3a plus 2b is equal to 3 times matrix A plus 2 times matrix B. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. Plus 2 times 2 is 4. 2 times negative 2 is negative 2. 2 times negative 1 is negative 2. 2 times negative 1 is negative 2. 2 times 3 is 6. The addition of matrix is the addition of the corresponding elements of two or more matrices of the same order. We have two matrices with the same order, that is 2 by 2, so we can add the corresponding elements. The first matrix, that is 3, 6, 9, 12, plus the second matrix 4, negative 2, negative 2, 6 is equal to 3 plus 4, 6 plus negative 2, 9 plus negative 2, 12 plus 8, which is equal to 3 plus 4 is 7, 6 plus negative 2 is 4, 9 plus negative 2 is 7, 12 plus 6 is 18. Choice C is the correct answer. Question number 5. What is the set of the values of k that the system x minus y plus z is equal to 3, 2x plus y minus z is equal to 4, kx minus 2y minus z is equal to 5 has a solution? Follow these steps to solve the problem. Write the equation in the form of a matrix. The first one is the coefficient matrix, that is the coefficient of variables in the first equation in row 1, 1, negative 1, 1. Row 2, the coefficient of the variables in the second equation, that's 2, 1, negative 1. Row 3, the coefficient of the variables in the third equation, k, negative 2, negative 1, times the variables x, y, z is equal to the numbers to the right of equality, that's 3, 4, 5. Step 2, determine the determinant of the coefficient matrix, because this is this matrix that determines whether the system has no solution, unique solution, or infinitely many solutions. If the determinant of the coefficient matrix is different from 0, then the system has a unique solution. If the determinant of the coefficient matrix is equal to 0, then the system has either no solution or infinitely many solutions. Thus, the determinant of the coefficient matrix is the determinant of the 3 by 3 matrix with first row 1, negative 1, 1, second row 1, 2, negative 1, and third row k, negative 2, negative 1, which is equal to, take first element of row 1, that is 1, and cross out row 1 and column 1, and we left with 1 times negative 1 minus negative 2 times negative 1 minus second element of first row, that's negative 1, and then cross out row 1 and column 2, we left with 2 times negative 1 minus k times negative 1 plus third element of row 1, that is 1, cross out row 1 and third column, we left with 2 times negative 2 minus k times 1, which is equal to 1 times negative 1 is negative 1 minus negative 2 times negative 1 is 2, negative 1 minus negative 1 means plus 1 times 2 times negative 1 is negative 2 minus k times negative 1 is minus k plus 1 times 2 times negative 2 is negative 4 minus k times negative 1 is minus k, which is equal to 1 times negative 1 minus 2 plus 1 times negative 2 minus negative k means plus k plus 1 times negative 4 minus k, which is equal to negative 1 minus 2 is negative 3 times 1 is negative 3 plus 1 times negative 2 is negative 2 plus 1 times k is k, 1 times negative 4 is minus 4, 1 times negative k is negative k, k minus k is 0, so we left with negative 3 minus 2 minus 4, negative 3 minus 2 is negative 5, minus 4 is negative 9. Since the determinant of the coefficient matrix is different from 0, the system has a unique solution. The system has a unique solution for all k. Thus, choice C is the correct answer. Question number 6. What is the set of parabola given by y squared plus 6y plus 8x plus 25 is equal to 0? Which one of the following is not true about this parabola? The square term of the parabola is y squared. Thus the parabola has a horizontal axis. The standard form of equation of a parabola having a horizontal axis is y minus k the whole square is equal to 4p times x minus h, where h comma k is the vertex and h plus p comma k is the focus. So let's rewrite the equation in standard form. Y plus 6y plus 8x plus 25 is equal to 0. Divide the coefficient of y by 2 and then deduct square of the quotient from y plus 3 the whole square. Thus y plus 3 the whole square minus square of 3 is 9 plus 8x plus 25 is equal to 0. Y plus 3 means y minus negative 3 the whole square plus 8x plus negative 9 plus 25 is 16 is equal to 0. Y minus 3 the whole square. Taking 8x plus 60 to the other side of the equality, we'll get minus 8x minus 60. Y minus 3 the whole square is equal to negative 8 is a common factor for negative 8x minus 16. So negative 8x divided by negative 8 left with x. Negative 16 divided by negative 2 is plus 2. This implies y minus negative 3 the whole square is equal to negative 8 means 4 times negative 2 times x plus 2 means x minus negative 2. So the value of p is negative 2, h is negative 2, k is negative 3. The focus, which is equal to h plus p comma k, is equal to h is negative 2 plus p is negative 2 comma negative 3, which is equal to negative 2 plus negative 2 is negative 4 comma negative 3. Choice B and C are true. Since the coefficient of x minus h is negative, that's negative 8, the parabola opens to the left, thus choice A is not true. For this horizontal parabola, the directrix is a vertical line located absolute value of p unit to the right of the vertex, or its vertical line passes through the order pair h plus absolute value of p comma k. H plus absolute value of p comma k is equal to h is negative 2 plus p is negative 2 comma k is negative 3. 2 plus absolute value of negative 2 is positive 2, so negative 2 plus positive 2 is 0 comma 3. The vertical line that passes through 0 comma negative 3 is the y-axis, so choice D is true. Choice A is the last alternative, meaning the statement which is not true is choice A. Question number 7. For what value of k does the system 2x minus y plus 4z is equal to 6, kx minus y minus z is equal to 2, x plus y plus 2z is equal to 8 has a unique solution? The system has a unique solution means the determinant of the matrix is different from 0. So the determinant of the coefficient matrix is a 3 by 3 matrix having elements of first row, that's the coefficient of first equation 2, negative 1, 4. Elements of second row, the coefficient of variables in second equation k, negative 1, negative 1. Elements of coefficient of the variables in the third equation, that's 1, 1, 2, different from 0. To determine the determinant of this matrix, take the first element of row 1, that is 2, then cross out row 1, column 1. We left with negative 1 times 2 minus 1 times negative 1 minus second element of the first row, that's negative 1. Cross out row 1 and column 2. We left with k times 2 minus 1 times negative 1 plus third element of row 1, that is 4 times. Cross out row 1 and column 3. We left with k times 1 minus 1 times negative 1. This should be different from 0. 2 times negative 1 times 2 is negative 2 minus 1 times negative 1 is negative 1 plus 1 times minus negative 1 is plus 1 times 2 times k is 2k minus negative 1 times 1 is negative 1 plus 4 times k times 1 is k minus 1 times negative 1 is negative 1, different from 0, which is equal to 2 times negative 2 minus negative 1 is plus 1 plus 1 times 2k is 2k, minus negative 1 is plus 1, times 1 is plus 1, plus 4 times k is 4k, 4 times k minus negative 1 is plus 1, this should be different from 0. This implies negative 2 plus 1 is negative 1, times 2 is negative 2, plus 2k plus 1, plus 4 times k is 4k, 4 times 1 is 4, different from 0. 2k plus 4k is 6k, minus 2 plus 1 is negative 1, negative 1 plus 4 is positive 3, different from 0. Take positive 3 to the other side of inequality and then divide it by 6. We will find k is different from negative 1 over 2. The correct answer is choice C. Question number 8. Let A is equal to a 2 by 2 matrix with elements of first row 2, 3 and elements of second row 2, negative 1. And B is equal to a 2 by 3 matrix with elements of first row 2, 5, negative 4 and elements of second row 3, 2, 6. Then A times B is A is a 2 by 2 matrix and B is a 2 by 3 matrix. Since the second order of A is the same as the first order of B, then multiplication of the two matrices is possible and the result is a matrix with an order 2 by 3. 2 is the first order of A and 3 is the second order of B. Knowing this fact will help you to decide that A and D can't be the answer, or the answer is either B or C. Knowing such facts help us to make systematic guess if we are running short of time or if we don't know how to solve the problem. Now let's solve the problem. AB is equal to matrix A, that's a 2 by 2 matrix having elements of first row 2, 3 times and elements of second row 2, negative 2 times matrix B, that is a 2 by 3 matrix with elements of first row 2, 5, negative 4 and elements of second row 3, 2 and 6. Follow these steps to determine this multiplication. First, determine the sum of a product of row 1 of matrix A with column 1 of matrix B, that's 2 times 2 plus 3 times 3. Second, determine the sum of the product of row 1 of matrix A with column 2 of matrix B, that's 2 times 5 plus 3 times 2. Determine the sum of the product of row 1 of matrix A with column 3 of matrix B, 2 times negative 4 plus 3 times 6. Fourth step, determine the sum of the product of row 2 of matrix A with the corresponding column 1 of matrix B, that's 2 times 2 plus negative 1 times 3. Fifth step, determine the sum of the product of row 2 of matrix A with the corresponding column 2 of matrix B, that's 2 times 5 plus negative 1 times 2. At last, determine the sum of the product of row 2 of matrix A with the corresponding column 3 of matrix B, 2 times negative 4 plus negative 1 times 6. 2 times 2 is 4 plus 3 times 3 is 9. 2 times 5 is 10 plus 3 times 2 is 6. 2 times negative 4 is negative 8 plus 3 times 6 is 18. Second row elements, 2 times 2 is 4 plus negative 1 times 3 is negative 3. 2 times 5 is 10 plus negative 1 times 2 is negative 2. 2 times negative 4 is negative 8 plus negative 1 times 6 is negative 6, which is equal to 4 plus 9 is 13. 10 plus 6 is 16. Negative 8 plus 18 is 10. 4 plus negative 3 is 1. 10 plus negative 2 is 8. Negative 8 plus negative 6 is negative 14. So choice B is the right answer. Question number 9. If P, the rainy season is very good this year, and Q, rivers are rising, then the statement, it's not true that neither the rainy season is very good this year, nor the rivers are rising, denoted by. In this statement, it's not true that neither the rainy season is very good this year, nor rivers are rising. The statement, the rainy season is very good this year, is represented by P. Then, neither the rainy season is very good this year will become negation of P. Again, the statement or the sentence, rivers are rising, is represented by Q. Then, nor rivers are rising will become negation of Q. The statement it's not true means negation. So the statement it's not true that neither the rainy season is very good this year nor rivers are rising can be expressed as it's not true means negation. Parenthesis, neither the rainy season is very good, negation of P. Neither nor or either or is represented by or, that's disjunction. Then the last one, nor the rainy seasons are rising, is negation of Q. So choice A is the correct answer. Question number 10, the distance between point 4, 3 and the line L, that's x plus y minus 7 is equal to 0 is the distance between point P, that's order pair x sub 1, y sub 1, and the line ax plus by plus c is equal to 0 is given by the formula distance is equal to absolute value of ax1 plus by1 plus c divided by square root of a square plus b square. From the equation, x sub 1 is equal to 4, y sub 1 is equal to negative 3, a is equal to the coefficient of x, that's 1, b is equal to the coefficient of y, that's 1 again, and c is a constant, that's negative 7. Then plugging the values to their appropriate place, we'll find d is equal to a means 1 times x1 means 4 plus b means 1 times y sub 1 means negative 3 plus c is negative 7 divided by square root of a square, that's 1 square, plus b square, again that's 1 square, which is equal to 4 times 1 is 4, 1 times negative 3 is minus 3, plus minus 7 means negative 7 divided by square root of 1 square is 1, so 1 plus 1. This is equal to 4 minus 3 is plus positive 1, positive 1 minus 7 is negative 6 divided by square root of 1 plus 1, that's square root of 2, which is equal to absolute value of negative 6 is positive 6 divided by square root of 2. Rationalizing the denominator, that's multiplying both the numerator and the denominator by root 2. 6 times root 2 is 6 root 2 divided by root 2 times root 2 is 2. 6 divided by 2 is 3 root 2. So the answer is through root 2. Choice B is the correct answer. Question number 11. The general form of the sequence A7 is equal to 1 over 2 the power of 1 minus n. Then which of the following is true about this sequence? The sequence A7 is equal to 1 over 2 the power of 1 minus n is equal to 1 over 2 the power of 1 plus negative n, which is equal to 1 over 2 the power of 1 times 1 over 2 the power of negative n. This is equal to 1 over 2 the power of 1 means simply 1 over 2 times 1 over 2 means 2 the power of negative 1, the whole power of negative n, which is equal to 1 over 2 times 2 the power of negative 1 times negative n is 2 the power of n. Thus, the terms of these sequences are, if n is equal to 1, 2 the power of 1 is 2, 1 over 2 times 2 is 1. If n is equal to 2, 2 the power of 2 is 4, 4 divided by 2 is 2. If n is equal to 3, 2 the power of 3 is 8, 8 divided by 2 is 4. If n is equal to 4, 2 the power of 4 is 16, 16 divided by 2 is 8. If n is equal to 5, 2 the power of 5 is 32, 32 divided by 2 is, or 32 times 1 over 2 is 16. So out of the given alternatives, choice B can be the answer. Question number 12. Let sequence A7 is a real number, then which of the following is true about this sequence? All the choices are referring about bounded sequence, so let's define a bounded sequence. A sequence A7 is bounded if it is bounded above and below. That's to say that if there is a number k less than or equal to all terms of the sequence, and another number m greater than or equal to all terms of the sequence, mathematically, this statement can be expressed as k less than or equal to a sub n, the sequence a sub n, less than or equal to m. So choice B is the right alternative. Question number 13. Which of the following is an upper bound of the sequence n plus 1 divided by n ranging from 1 up to infinity? N plus 1 over n is equal to, split this rational expression into 2, that's n over n plus 1 over n, which is equal to n over n means 1, plus 1 over n is as it is 1 over n. Let's see some of the terms to understand the pattern. If n is equal to 1, then 1 plus 1 over n is equal to 1 plus 1 over 1. 1 over 1 means 1, so 1 plus 1 is 2. If n is equal to 2, then 1 plus 1 over n is equal to 1 plus 1 over 2. 1 over 2 means 0.5, so 1 plus 0.5 is equal to 1.5. If n is equal to 50, then 1 plus 1 over n is equal to 1 plus 1 over 50. 1 over 50 means 0.02, so 1 plus 0.02 is equal to 1.02. If n is equal to 1000, then 1 plus 1 over n is equal to 1 plus 1 over 1000. 1 over 1000 means 0.001. 1 plus 0.001 is equal to 1.001. 1 is there in all terms of the sequence. 2 is the greatest term of the sequence. As n approaches to infinity, 1 over n approaches to 0, and hence 1 plus 1 over n approaches to 1. Thus, the sequence is bounded between 1 and 2, that is 1 less than. The sequence n plus 1 over n less than or equal to 2. 2 and numbers greater than 2 are upper bounds. 1 and numbers less than 1 are lower bounds. So choice A is the right answer. That is the upper bound from the given alternatives is number 2. Question number 14. Which of the following is a lower bound for the sequence n over n minus 1, n range from 1 up to infinity? N over n minus 1 is equal to 1 the whole over n minus 1 over n. N at the numerator becomes n at the denominator of the denominator, which is equal to, let's split the denominator n minus 1 over n into n over n minus 1 over n, which is equal to 1 over n over n means 1 minus 1 over n. Again, let's list sum of the sequence. 1 can't be an element of this sequence because it makes the denominator 1 minus 1 over n 0. So the next term is 2, since n is a natural number. If n equal to 2, then 1 over 1 minus 1 over n is equal to 1 over 1 minus 1 over 2. 1 over 2 is 0.5, so 1 minus 0.5 is 0.5. 1 divided by 0.5 is equal to 2. If n is equal to 10, then 1 over 1 minus n is equal to 1 over 1 minus 1 over 10. 1 over 10 means 0.1. 1 minus 0.1 is 0.9. 1 divided by 0.9 is 1.111. If n is equal to 500, then 1 over 1 minus 1 over n is equal to 1 over 1 minus 1 over 500. 1 over 500 means 0.002. 1 minus 0.002 is equal to 0.998. 1 divided by 0.998 means 1.002. 2 is the greatest term of the sequence. As n approaches to infinity, 1 over n approaches to 0, then 1 minus 1 over n approaches to 1, and hence 1 divided by 1 minus 1 over n approaches to 1. Thus the sequence is bounded from the left by 1 and from the right by 2, that is 1 less than n over n minus 1, less than or equal to 2. 2 and numbers greater than 2 are upper bounds. 1 and numbers less than 1 are lower bounds. Thus choice D is the right alternative, or the only lower bound from the given alternatives is 1. Question number 15. Let x squared plus y squared plus kx is equal to 1 be equation of a circle for some k element of a real number. What is the radius of the circle if center is 2, 0? The standard form of equation of a circle is x minus h the whole square plus y minus k the whole square is equal to r square. where h, k is the center and r is the radius of circle. So the given equation can be rewritten in the form of standard equation plus x squared plus y squared plus kx is equal to 0. This implies divide the coefficient of x by 2, then write the equations as x plus k over 2 the whole square minus the square of the positive term inside the bracket, that's k over 2 square. K square is k square, divided by 2 square is 4, plus y minus 0 the whole square is equal to 1. X plus k over 2 means x minus negative k over 2 the whole square plus y minus 0 is equal to, if we take negative k over 4 to the other side of the equality, we find 1 plus k square over 4. In this expression, negative k over 2, 0 is the center, and 1 plus k square over 4 is equal to radius square. And the center of the circle is given as 2, 0, thus negative k over 2 is equal to 2. This implies k is equal to negative 4. We find out in the above equations that r square is equal to 1 plus k square over 4. This implies taking the square root of both sides, we'll find the square root of r square, simply r, is equal to the square root of 1 plus k square over 4, which is equal to square root of 1 plus k means negative 4 square divided by 4, which is equal to absolute value of 1 plus negative 4 square is 16 divided by 4. 16 divided by 4 means 4. So square root of 1 plus 4 is equal to square root of 5. The correct answer is choice D. Question number 16. If the inverse of the matrix, that's a 2 by 2 matrix with elements of first row x to x and elements of second row negative x, x is a 2 by 2 matrix negative 1 with elements of first row negative 1, negative 2 and elements of second row 1, 1, then which one of the following is the value of x? The inverse of a matrix A having elements of first row A, B and elements of second row C, D is given as A inverse is equal to 1 over the determinant of A, that is AD minus BC, times this matrix, that's switch A and D and multiply B and C by negative. Then if A is equal to the 2 by 2 matrix with elements of first row, that's x to x and elements of second row negative x and x, then A inverse is equal to 1 over the determinant of A, that's x times x is x squared minus negative x times 2x is negative 2x squared times this matrix, switch A and D, that's switch x by x, the same x, multiply 2x by negative, that's negative 2x, multiply negative x by negative, that is positive x, which is equal to the inverse matrix, that's a 2 by 2 matrix having elements of first row negative 1, negative 2 and elements of second row 1, 1. This implies 1 divided by x squared minus negative 2x squared means plus 2x squared times the matrix with elements of first row x, negative 2x, elements of second row x, which is equal to negative 1, negative 2, 1, 1. This implies 1 over x squared plus 2x squared is 3x squared times x, negative 2x, x, which is equal to negative 2, negative 1, 1, 1. This implies 1 over 3 outside the bracket, multiply all the stuffs inside the bracket, thus 1 over 3 x squared times x is 1 over 3x, 1 over 3x squared times negative 2x is negative 2 over 3x, 1 over 3x squared times x is 1 over 3x, 1 over 3x squared times x is 1 over 3x, which is equal to the inverse matrix, that's negative 2, negative 1, negative 2, 1, 1. Taking any one of the terms at the left and equate it with the corresponding terms at the right, that's first element of the left side matrix, that's 1 over 3, is equal to first elements of first row of the right side matrix, that's -1. Second elements of first row of the left side matrix, that's -2 over 3x is equal to second elements of first row of the right hand side matrix, that's -2. First elements of second row of the left hand side matrix, that's 1 over 3x is equal to first elements of second row of the right hand side matrix, that's 1. Second elements of second row of the left hand side matrix, that's 1 over 3x is equal to second elements of second row of the right hand side matrix, that's 1. In all cases, we have to find similar result. In case 1, that's 1 over 3x is equal to -1. This implies multiplying crisscross. 1 times 1 is 1. 3x times -1 is -3x. This implies divide both sides by -3, then x is equal to -1 over 3. In equation 2, -2 over 3x is equal to -2. -2 means -2 over 1. So -2 cross out by -2, we left with 1. Then 1 over 1. 1 divided by 3x is equal to 1 over 1. 3x times 1 is 3x, which is equal to 1 times 1 is 1. Divide by both sides by 3, we'll find x is equal to 1 over 3. In equation 3 and equation 4, they are similar equations. 1 over 3x is equal to 1. This implies 3x is equal to 1. Dividing both sides by 3, we will find x is equal to 1 over 3. In alternative 1, we find -1 over 3 as a solution, and in the rest of the 3 alternatives, we find x is equal to 1 over 3 as a solution. This is an indication that the question is not correct, so none of the alternatives can be the answer. The question will be correct if the second x of second row is given as -x. If so, the answer will be x is equal to 1. Question number 17. Given 0 less than a7 less than 1 over n, for n is equal to 1, 2, 3, ... Which of the following is true? From the given, we can understand that a7 is a fraction between 0 and 1 over n. Say 1 over n plus 1, 1 over n plus 5, 1 over n plus c. Hence, limit of a7, n approaches to infinity is equal to 0. So choice D is the correct answer. Question number 18. Limit of x minus 2 over x, the whole power of -2x plus 1, as x approaches to infinity, is equal to blank. From the special property of limit, we know that limit of 1 plus 1 over x, the whole power of x, as x approaches to infinity, is equal to e. So let's rearrange the given expression to get this form. Limit of x minus 2 over x, the whole power of -2x plus 1, as x approaches to infinity, is equal to limit of x minus 2 divided by x, the whole power of -2x, as x approaches to infinity, times x minus 2 divided by x, the power of 1, which is equal to limit of x minus 2 over x, the whole power of -2x, as x approaches to infinity, times limit of x minus 2 divided by x, the whole power of 1, as x approaches to infinity. Let's split the terms inside the bracket, then we'll find limit of x divided by x minus 2 over x, the whole power of -2x, as x approaches to infinity, times limit of x over x minus 2 over x. The power of 1 means simply the expression itself, as x approaches to infinity, which is equal to limit of x divided by x is 1 minus 2 over x, as x approaches to infinity, times limit of, again here x divided by x is 1 minus 2 over x, as x approaches to infinity, which is equal to limit of 1 minus 2 over x, the whole power of -2x, as x approaches to infinity. As x approaches to infinity, 2 over x approaches to 0, so 1 minus 0 is 0, 1 minus 0 is 1, so the limit of the second expression is simply 1, which is equal to 1 times this first limit is simply the limit itself, that's limit of 1 minus 2 over x, the whole power of negative 2x as x approaches to infinity. Let negative 2 over x is equal to positive 1 over y. Making cross multiplication, negative 2 times y is negative 2y is equal to 1 times x is x. Thus, the limit of 1 minus 2 over x, the whole power of negative 2x as x approaches to infinity is equal to limit of 1. We substitute negative 2 over x by plus 1 over y. The whole power of negative 2 times x means negative 2y as y approaches to infinity, which is equal to limit 1 plus 1 over y. The whole power of negative 2 times negative 2y means 4y as y approaches to infinity. This power can be rewritten as limit of 1 plus 1 over y, the whole over y, the whole over 4 as y approaches to infinity. The limit of the expression inside the brackets, that's 1 plus 1 over y, the power of y as y approaches to infinity is e. The power of 4 means e the power of 4. The correct answer is choice C. Question number 19. If f of x is equal to k times 2 the power of x, if x is greater than 2, and x cubed minus x plus 1 if x is less than or equal to 2, for what of k is continuous at x is equal to 2? From the second expression, we can determine f of 2 as f of 2 is equal to 2 cubed minus 2 plus 1. 2 cubed is 8, minus 2 plus 1. 8 minus 2 is 6, 6 plus 1 is 7. Taking the first expression and equate it to 7, that is k times 2 the power of x is equal to 7. K times 2 the power of x is 2, which is equal to 7. 2 the power of 2 is 4. K times 4 is equal to 7. Dividing both sides by 4, we'll find k is equal to 7 over 4. The correct answer is choice C. Question number 20. What is the slope of a tangent line of the graph of f of x is equal to x squared plus tan x at pi comma f of pi? First, let's determine the derivative of f of x. F derivative of x is equal to the derivative of x squared is 2x plus the derivative of tan x is secant square of x. F derivative at pi is equal to 2 pi plus secant square of pi. Secant pi is negative 1. Negative 1 square is positive 1. So f derivative at pi is equal to 2 pi plus 1. That is the slope of the tangent line. So choice A is the right alternative. Question number 21. Let f of x is equal to x squared plus 2x plus 3. Find number c between 1 and 3 such that f derivative of c is equal to f of 3 minus f of 1 divided by 2. Without going for further calculation, we can reply that choice P is the answer, because out of the given alternatives, only number 2, that's choice P, is found between 1 and 3. But for your understanding, let's go through the steps. F derivative of x is equal to the derivative of x squared is 2x plus the derivative of 2x is 2 plus the derivative of 3 is 0, because the derivative of any constant is 0. F derivative at c is equal to, substitute c in place of x, which is equal to 2c plus 2. This equal to the given, that's f of 3 minus f of 1 divided by 2. This implies 2c plus 2 is equal to f of 3 is 3 squared plus 2 times 3 plus 3 minus f of 1, substitute 1 in place of x. We'll find 1 squared plus 2 times 1 plus 3 divided by 2. This implies 2c plus 2 is equal to 3 squared is 9 plus 2 times 3 is 6 plus 3 minus 1 squared is 1 plus 2 times 1 is 2 plus 3 divided by 2. This implies 2c plus 2 is equal to 9 plus 6 is 15 plus 3 is 18 minus 1 plus 2 is 3 plus 3 is 6 divided by 2. This implies 2c plus 2 is equal to 18 plus minus 6 is 12. 12 divided by 2 is 6. This implies 2c is equal to 6 minus 2, that is 4. Divide both sides by 2. We will find c is equal to 2. choice B is the answer. Question number 22. The product of two positive real numbers is 100, such that the sum of 2 times the first number and 8 times the second number is minimum. Which of the following pairs of numbers are the first and second numbers respectively? Let x and y are two positive real numbers. Then x times y is equal to 100, that's their product is equal to 100. 2 times the first number, that's 2x, plus 8 times the second number, that's 8y, is the minimum. Let's say it's f of x. From equation 1, let's rewrite y in terms of x as y is equal to 100 over x, provided that x is different from 0. Hence, f of x is equal to 2x plus 8 times y means 100 over x, which is equal to 2x plus 8 times 100 is 800 over x. The minimum is achieved at critical numbers. Critical numbers are those numbers at which f derivative of x is equal to 0 or f derivative of x doesn't exist. We know f of x is equal to 2x plus 800 over x. Then f derivative of x is equal to, the derivative of 2x is simply 2 plus 800 times the derivative of x to the power of negative 1, which is equal to 2 plus 800 times the derivative of x to the power of negative 1 is minus 1 times x to the power of negative 2, which is equal to 2 times 800 times negative 1 is negative 800. X to the power of negative 2 means x squared divided by x squared. F derivative of x doesn't exist at x is equal to 0 because x squared is at the denominator, but we already specified that x should be different from 0. So let's solve for x. F derivative of x is equal to 0. We determine f derivative of x as 2 minus 800 over x squared is equal to 0. Then to solve this expression, simply switch 2 and x squared. This implies x squared is equal to 800 over 2. Taking the square root of both sides, square root of x squared is x, is equal to 800 divided by 2 is 400. So take the square root of 400. Square root of 400 is 20. That means x is 20. If x is 20, y is equal to 100 over x. This implies y is equal to 100 over 20, which is equal to 5. Therefore, the two positive real numbers respectively are 20 and 5. So choice D is the correct answer. Question number 23. Which of the following is zeros of a function f of x is equal to x cubed minus 3x squared plus 3x minus 1? Zeros of a function is computed as f of x is equal to 0. F of x means x cubed minus 3x squared plus 3x minus 1 is equal to 0. To factorize this expression, let's find a number that makes the expression 0. If we substitute 1, we will find 1 cubed minus 3 times 1 squared plus 3 times 1 minus 1 is equal to 0. The sum of the left-hand side expression is equal to 0. If 1 makes the expression 0, then x minus 1 is the factor. So x cubed minus 3x squared plus 3x minus 1 divided by x minus 1 gives us x squared minus 2x plus 1, which is equal to 0. The second expression inside the second bracket, that's x squared minus 2x plus 1 means x minus 1 the whole square times x minus 1 is equal to 0. X minus 1 times x minus 1 the whole square means x minus 1 the whole cube is equal to 0. This left-hand expression equal to 0 only when x is equal to 1. Thus, the right alternative is choice A. Question number 24. If f of x is equal to ln 2 divided by x squared, then f derivative of x is equal to, if f of x is equal to g of x over h of x, then the derivative of f of x is equal to the derivative of the numerator, that's the derivative of g of x, times the denominator, that's h of x, minus the derivative of the denominator, that's h derivative of x, times the numerator, g of x, divided by the denominator square, that's h of x squared. In the given expression, g of x is equal to ln 2 and h of x is equal to x squared. Thus, f derivative of x is equal to the derivative of ln 2, that is 0 times x squared, minus the derivative of x squared is 2x times ln 2, divided by the x square, the whole power of 2. 0 times x square is 0 minus 2x ln 2 means negative 2x ln 2 divided by x square the power of 2 means x the power of 4, which is equal to 1x as the denominator, cross out 1x as the denominator, then we left with negative 2 ln 2 divided by x cubed. So the correct answer is choice C. Question number 25. What is the value of limit sine 4x divided by sine 6x as x approaches to 0? It's known that limit sine x divided by x as x approaches to 0 is equal to 1. So let's rewrite this limit sine 4x divided by x to the form sine x divided by x. Limit sine 4x divided by sine 6x as x approaches to 0 is equal to multiply both the numerator and the denominator by 1 over x. That gives us limit sine 4x times 1 over x divided by sine 6x times 1 over x as x approaches to 0, which is equal to limit sine 4x times 1 over x as x approaches to 0 divided by limit sine 6x times 1 over x as x approaches to 0. Mathematically, it is possible to multiply both the numerator and the denominator by the same number, because dividing the number by itself gives us 1, and hence multiplying the number by 1 is the number itself. So let's multiply the numerator and the denominator by the coefficient of x. The coefficient of x at the numerator is 4, so multiply 1 over x by 4 over 4 as the numerator, and the coefficient of x at the denominator is 6, so multiply 1 over x at the denominator by 6 over 6. Then we will find limit sine 4x times 4 times 1 is 4 divided by 4 times x is 4x as x approaches to 0 divided by limit sine 6x times 1 times 6 is 6 divided by 6 times x is 6x as x approaches to 0, which is equal to limit sine 4x divided by 4x times 4 at the numerator as x approaches to 0 divided by limit sine 6x divided by 6x times 6 as x approaches to 0, because multiplication is commutative. If limit of sine x divided by x as x approaches to 0 is equal to 1, then limit of sine 4x divided by 4x as x approaches to 0 is 1 times 4 as the numerator divided by limit of sine 6x divided by 6x as x approaches to 0 is 1 times 6 as the denominator. 1 times 4 is 4 divided by 1 times 6 is 6. 4 divided by 6 means 2 over 3. Thus choice D is the correct answer. That's all for this lesson. Subscribe, like and share this YouTube page. See you later.